All right, thank you everyone for attending. Today I'm going to be talking about how we can use Graph to detect money laundering and fraud and kind of some of the problems that arise from those things existing in the world, some of the issues that we currently have with today's processes, how Graph can fix those, and a little bit more kind of on the overall power of Graph and how it fits into these types of use cases, whether it be actual money fraud or other types of fraud that we can detect using Graph databases. So go ahead and I'll kick things off. So a little bit about me, I guess to start, I am a developer advocate at TigerGraph. What that means is I'm in charge of kind of building out these types of presentations, education to help teach people about TigerGraph, how to use it, as well as to help build out connectors and examples so that way people can integrate TigerGraph with the products that they already use and basically make the process a lot more seamless for people who are trying to get interested in TigerGraph and use it in real world scenarios. Previously, I'd worked at a large healthcare tech company, and that was kind of the first place where I started using TigerGraph as a product. And ever since then, I've been sold on it. And I truly do believe that the Graph way of thinking is kind of the next step forward in terms of the evolution of how we consume and interact with data in the real world. So I guess I'll kind of set the stage first. Fraud is bad, as we all probably know, but to understand how bad it is, we have to throw some numbers on it. So there are about $56 billion lost to fraudulent transactions worldwide every year, or last year at least, that's of 2020. But the interesting thing is that only 1 in 5 block transactions are actually fraudulent. So there's a huge problem right now with false positives in terms of identifying fraudulent transactions. I'm sure a good portion of people on this call have gotten one of those notifications from your banking app on your phone saying, hey, you really want to make this transaction? Was this you? When in reality, it was you. And yes, you did want to make that transaction. And for whatever reason, the bank blocked it because they thought it was suspicious. So that is something that happens a lot. And in fact, it happens a lot more frequently than we would like. And there are actually costs involved in that happening. You know, those transactions getting canceled, if they have to be redone, there's now that new transaction cost. Possibly it could result in a loss of sale. If I go to buy something and my credit card doesn't go through, you know, I can't buy that thing. Maybe I didn't check my app immediately to see that, you know, that it had been blocked or whatever. But the point is, while there's 56 billion in loss, there's 118 billion in blocked sales just in the US. So that's kind of that other 4 out of 5 of those actually fraudulent transactions. So that's something that we're looking to reduce because, you know, 15% of cardholders experience blocked sales, and that is huge compared to what is actually fraudulent. Some more just fun stats here. High-income consumers are more likely to be at risk of false positives, as are younger consumers. So if you're young, you're making a decent amount of money, you're probably going to get a lot of false positives on your transactions. You know, we've all been there. You're visiting another city, you make a large purchase there, your credit card says, hey, why are you, you know, buying $4,000 worth of stuff in Alabama when you live in Connecticut? You know, that might be blocked as a bad transaction. So with the current ways that things are being done, I guess, kind of as described here, we can see why those happen. So right now, the way that a lot of these fraud detection works is rule sets. So there's not much intelligence behind it. It is purely if you are spending more than X amount of money and you are not within X radius of your standard location, then we're going to add those to a potentially fraudulent score. And if that score is high enough, then we're going to block your transaction. So as you can tell, it's kind of very rule-based. There's no smart way to go about it to say, oh, we saw that you recently bought a plane ticket to Alabama, and now that you're in Alabama, you're buying things. You know, there's no way to say, oh, we acknowledge that you're in Alabama, and therefore these purchases that you're making in Alabama are probably okay. We instead say, hey, you're really far from home and spending a lot of money, so we think that this is someone else with your credit card number. So these traditional approaches also don't really cover all of the different types of fraud that there is. Like I said, because they're rule-based, they're not fully able to understand more complex types of fraud, things like chargeback credit card fraud, or potentially even things like fake Amazon reviews. That's a type of fraud. And we can use Graph to help detect those things, where something like our more traditional systems might not have been able to as easily identify that due to those strict rule sets. Additionally, a lot of these systems don't run, these existing systems don't run continuously. So what this means is at the end of the day or at the end of the week or whatever their cycle is, they run the report to generate these new fraud rankings for the transactions that took place. And obviously, hourly or even daily are just unacceptable in terms of performance. You need something that is real time, down to the minute. I make a transaction, I want to immediately know if this is potentially fraud. So something that we can improve already on these systems is that real-time interoperability of gaining these insights. Additionally, like I alluded to earlier, they're very false positive heavy, lots of overhead in terms of the rule sets, and lots of overhead comes out of all of those false positives. You have to, if 4 out of 5 of your investigations result that there is not actually fraud happening, then you're essentially wasting 80% of your time. So how do we eliminate those false positives and gain further insights into what is actually happening? Then lack of speed and scale. A lot of this is done on data in traditional relational databases. Complex joins need to be done between different tables of, cardholder versus transaction versus merchant, things like that, where we need to look at all of these different aspects in order to gain a holistic picture of what is actually going on. And speaking of that, that is where Graph comes in, gaining that holistic picture. That is the core functionality of Graph, is the ability to bring in all of these disparate data sets and look at them as if they were one highly connected data set. The value of the insights that you gain from looking at one data set is multiplied exponentially when you start bringing those data sets together. So as soon as we can bring all those tables together and look at them as a whole, there's so much more insight than you can get if you were to just look at each table on its own and combine those insights to each other. So let's start with a couple different types of financial fraud. I'll briefly list them out here. We'll go into a little bit more detail on each one of them, and then we'll go into a little bit even more detail on how Graph can help solve those problems. And then sort of at the end of this, I'm going to show you a actual functioning graph that you could spin up on your own completely for free that demos a lot of these fraud type use cases. And we'll get a pretty good idea of just all of the things that you can do by loading your financial or other data into TigerGraph with the intention to look for fraud. So actually, as a little side note, something that I want to put out there, when I first started using TigerGraph, I inadvertently found fraud. I was not looking for it. I was looking for something completely different in the data set. But when I brought that data set together within Graph and I was able to see it within that view, I was not only able to find what I was looking for, but I also found fraud happening. And that was just one of those things that really sold me on the power of Graph, is if I can be looking for one thing and yet this technology makes it so blatant that this other thing is going on that I cannot miss it, then that's of a huge value to me. If I can, if I can see things that I wasn't expecting to see, if I can gain additional unknown value from what I'm working with, then it's absolutely a huge opportunity. And that was really what sold me that Graph was something so powerful, is that all of these insights are there. They're just waiting for someone to look in the right way to see them. So getting back to fraud, phone scam. So this is kind of I'm sure we've all been there, getting a robocall from some random number. It is absolute garbage call. It's just looking to get your personal information. And frankly, I want none of those to ever happen again. So how can we look at who's calling who and what a good phone call versus a bad robocall looks like? Credit card chargeback fraud. So this kind of takes 2 separate categories. So one of these is your traditional, someone stole my credit card. They used it to buy a bunch of things, but fortunately I'm proactive and I called and canceled my credit card and I'm trying to get my money back. The issue here is that the person who stole the card bought the things, they gained the actual products, yet me not wanting to lose my money and canceling my card issued a chargeback so that way I get my money back because I didn't actually buy those things. Now here's the issue. The person who stole my card still has the items that they paid for with my money, and yet I still have my money because I issued the chargeback. So someone down the line of either the vendor who sold the product or the bank who holds my money is going to lose. There's no other way about it. I get my money back, the person has their product. So therefore, in the middle, either the vendor or the bank is going to lose either that money or that product that they sold out. And that's not good for them. Additionally, we have advertising fraud. So this is more of your fake Amazon reviews. This is that type of fraud. Or something like I have an incentive program, like an ad program where based on a number of clicks, I get rewarded money for that advertising. So if I had some sort of script or a bunch of people who I told to click this button, and that would gain me advertising revenue, or something whereas if I had a series of products on a website like Amazon, and I wanted a bunch of 5-star reviews on those products because I want people to buy them, then I might go through some process to generate a bunch of fake reviews that are 5 stars. So how do we recognize that there are fake reviews, and how do we tell them apart from the real ones? And lastly, a big one is money laundering. I have a bunch of money that I obtained through less than legal methods, and I'm looking to clean that money so it looks like I obtained it through legal methods. How do we detect what those money laundering rings look like, and how can we use Graph to identify them sort of while they're in flight? So let's step through chargeback fraud a little bit. So like I said before, this is kind of 2 scenarios of either I stole a credit card and I bought something and that card was canceled because the person who had it stolen from them didn't want to spend that money. Or this also takes the case of I bought something that I don't actually want to pay for. I bought something, say I bought like a nice TV or something, and I say, ooh, $1,200 is a lot of money. I'll just cancel my credit card. I'll get my money back. I'll say it was stolen, but I still have my nice TV and I still have my $1,200. Sounds like a good deal. Well, not to the bank, not to the person who sold the TV. So how can we recognize those types of scenarios? So yeah, kind of going through there, fraudsters often resell that product. So like I said, $1,200 TV, I buy it, I get my $1,200 back through my chargeback. I sell my $1,200 TV for $1,000 on Facebook Marketplace. Hey, I just made $1,000. No problem. Sounds like a great deal. Let's see. Card owner. Yeah. So it's just kind of all basically what I was describing before. So let's take a look at how we can detect it with Graph. So normally this would be something that's kind of hard to detect normally because you have all of these just look like transactions, right? And they have a chargeback on them. But the problem is we have perfectly valid reasons for chargebacks. There are plenty of reasons where a merchant didn't deliver what they said they were going to deliver. And there are these actual scenarios where there are chargebacks. So we can't just blatantly go and say anyone who does a chargeback is fraudulent. That's how we end up with all of our false positives. So how can we use this data within a graph context to more intelligently approach those scenarios? So let's take, for example, this instance here. So account 1 is our active account. This is our new account that we just created. And it is linked to a credit card or a bank account. That's sort of what this green node is representing. But then we can also see that linked to that card or account is this other account. So this account had already existed. Maybe it had this card on it and we're adding a second person to the card, but we can see that this account had made these 4 transactions. Now, an unsettled transaction is not necessarily a fraudulent transaction. It's just a transaction that hasn't gone all the way through. So a settled transaction means I purchased something and the money went through and everything's good. Unsettled means I put in that request to buy something, the money has not yet transferred, but that transaction has still technically happened. And chargeback means that the transaction went through, and then for whatever reason, the person requested the money back. So we can see here that this account has some unsettled transactions, but it has 1 chargeback, which, like I said before, doesn't necessarily mean anything. That could be an actual reason for needing a chargeback. But we can then see that linked to account 2, we have a card which was canceled for whatever reason. So that could have been validly canceled, due to this chargeback that could have been stolen. We don't know. But additionally linked to that account, we have a device, some sort of cell phone or a computer that was used to access that account. So that already kind of gives us a great point. If we have a device and we have if we have 1 person using that device, you're not typically going to the library to log into your bank account on some sort of public computer. That's typically something you do on your own personal device for that sensitive information. So now we can see that that device was also used to access this other account. okay, now this other account has a bunch of chargebacks and an unsettled transaction, as well as a previous device which was blocked. So now we're starting to get a better idea of our situation. So account one isn't just a new account that's linked to a credit card. This is now a new account that's linked to a credit card, which was formerly linked to two separate accounts, both of which had a high likelihood of having chargebacks on them. So now we can tell that most likely account one is the same fraudster that created account two and account three, now creating a new account because it's tied back to this credit card, which is tied to those fraudulent accounts before. And we can now say, we're not going to let you create this account. This is most likely a fraudulent account, and we know that now. So that's kind of how these interconnections between these different data sets and the ability to easily traverse them gives us a good idea of how we can recognize these situations, either as they're happening or before they even happen in some scenarios. Next up is kind of that recommendation fraud. So this is, like I was talking about, those Amazon reviews, those pay-per-click ad impressions, things like that. And again, let's take a look at how Graph can help us identify those. So say, for example, we have an Amazon review, and an Amazon account has posted a glowing 5-star review for this product, which is unfortunately garbage. Now, this product is padded with all of these 5-star reviews, but it's a 2-star product. So how do we recognize which of those reviews are actually real and which of them are fake? And we can do that by linking back those reviews to the account that created them. So say a manufacturer has 5 different products, and an account has submitted reviews for all 5 of those products. Okay, now we can look at the rest of the reviews and, oh, hey, all of these accounts have also reviewed these 4 other products by this manufacturer. Maybe they've also reviewed some other things, but we can see now that there's these direct connections. If these accounts are only reviewing products from this manufacturer and they're only giving it 5 stars, then there's probably a pretty good chance that there's something suspicious going on there. So a lot of the way that this works in the real world is, you hire someone who runs this type of service that has either bots or they pay real people to actually write these reviews. So you can see by tying those reviews together and the other products that they've reviewed, you can get a good understanding of where those reviews are actually coming from and if they're being manipulated by someone who is trying to pad their product with a bunch of good reviews. But sort of one of the underlying things, which I'll touch on more later, but one of the underlying things that we can get from Graph, and we can see this in this previous example as well, is that before, the only data that we had were these circles. We only had the account data, we only had the cart data, we only had the device data. But now what we have are all of these connections between them. So if you're looking at this from something like a machine learning standpoint, you can think of these as your features, right? So before, you might have a feature of something like transaction amount or transaction time or who the transaction went to. And those are really all you had. But now that everything's connected with Graph, I not only can know, okay, transaction amount, transaction time, I can know that this comes from a user, they have this number of total transactions, this is the average amount of each transaction that they do. These are each of the people that they've made those past transactions with, and who have those people interacted with? Does this transaction make sense within the context that it is currently in? So that's kind of these features that we can extract from there. And additionally, we can look at those within our product review case as well, where we can not only just view that one review in the context of that one product, but now we have the features of all of the other reviews that account has submitted. What is the content of those reviews? What are the actual words that are in them? Do they match some sort of pattern where they may have been machine generated, or there's some sort of copy and paste? So we have all these different aspects that we can view now because everything is connected to each other within this graph schema. And then finally, that whole connection kind of brings us into money laundering. Money laundering is actually a really visually cool thing to represent within the graph, and I'll get to that a little bit later on with the live demo. But money laundering is, of course, the process of taking dirty money and making it clean. So you may get a bunch of money from a illicit transaction, and now in order to put that money in the bank, you need to instead funnel it through a bunch of different potentially legal looking transactions. But what this involves in is typically person gets amount of illicit money, They then give it to someone else through the form of buying a service or something. And then that money gets passed around through a couple different people or entities until it makes a round trip back to the person who was initially had it. So I take my dirty money, I put it through this money laundering fraud ring. That money goes through enough steps where eventually it comes back to me in the form of like a paycheck or something that looks valid. And now I have all of my dirty money in the form of clean money. So what we're looking for here in fraud rings and money laundering is really that ring, that circling back to the initial person of that initial amount of money or slightly less. You know, you got to pay your fees here and there. But what we're looking for is that circle back to the initial person. And that makes for a really cool graph display. We'll get to that. But that is one of those things that can be very tough to tell in a traditional sense, where you have to monitor kind of each one of those transactions, who they're going to, because a lot of those entities that are getting these money laundering transactions are actually legitimate entities that are doing a bunch of legitimate transactions as well. So how do you tell apart what is this money laundering and what is just a standard business expense? And this is kind of a image representing that, and sort of the model of what we can do and what a solution would look like using Graph for money laundering, in addition to some machine learning as well. I won't get too much into this. We'll see it through the actual Graph demo, but sort of this is kind of what that pipeline looks like in terms of bringing in that real-time data into a Graph database, generating features based off of that then now connected graph structure, using those additional features for machine learning, loading them back into the graph so you can gain further insights, and then being able to use that to actually realize in real time when something like money laundering may be happening. So this is just kind of a real world use case. Tier 1 US bank wanted to better detect credit card and debit card fraud. So they wanted to do that by using PageRank and a couple of different graph algorithms in order to get a better understanding of their data. And you can see here that it's pretty impressive, some of the things that were in there and that they were able to do with Graph and TigerGraph specifically. Mainly, they leverage their analytics with 20+ terabytes of live data. And with all of this data loaded in one place, with all of the additional insights that they were able to gather from using a graph database, they were able to return over $50 million of lost ROI within their first year. So that's something pretty huge to be able to identify $50 million of fraud that you could not see before. And in addition to that, greater than $1.5 million per year of cost savings due to fewer false positives. So just due to the nature of this, fewer false positives, less things you have to waste your time on, and more things that you can notice that you didn't notice before that you can take that time and spend them on to actually recover money from these types of fraud situations. So this kind of goes into a little bit more detail about what I was talking about before with using Graph as an addition to machine learning in order to generate those different features that you can now extract to feed into a machine learning model. So kind of on the left here is your traditional relational database and the features that you could typically see from within your table and by doing some basic joins. And on the right is kind of all of the features that you can extract now that you have everything loaded into Graph, and you have the addition of those edges and those connections between your vertices instead of just your data. So as you can see, there are significantly more features that you can generate. Will all of those be useful? Maybe not, but the fact of the matter is that some of them are going to be. And the fact that you can now realize those is going to grant you that additional insight into your data and the additional performance that you need out of your machine learning models when you do go to predict or prevent fraud in the future. So here's a pretty good example of describing phone fraud. So this is like I was talking about before with those robocalls. So on the left, we have what is known as a good phone. You know, this is an average person. This is not fraud. You can see that they have a stable group. So this is kind of the people that they talk to on a regular basis, you know, their family, their friends, whoever it may be that they're regularly making calls to and receiving calls from. Additionally, there is in-group connections. So this would be something like family. You know, I call my mom, I call my dad, I call my sister. My mom also calls my sister. My dad calls my mom, things like that. So that's kind of an in group where I'm talking to this group of people. They also talk to each other. Additionally, you have kind of these friendship loops that you'll notice as well. Person A talks to person B. Person A also talks to person C. Person C talks to person B. That's kind of this three-step friendship relationship that you can get by recognizing. So this is what a good phone looks like. This is what an actual human being looks like, making actual phone calls to people. This is what a bad phone looks like. This is a robocaller. So first off, it does not have a stable group. No one wants to call back a robocaller. So it's not going to be getting any returned calls. It's going to be making a bunch of calls to numbers and probably not receiving many in return. Additionally, a lot of those calls are going to get rejected. I personally don't answer a number that I don't know when it comes through my phone. So I'm going to reject that call, send it straight to voicemail. And that happens a lot with these robocalls. Lastly, you'll kind of notice that there's no real, for the calls that do get picked up, there's no real connection between the people who pick them up. You know, I may be robocalling someone in New York, and I may be calling someone in Oklahoma, and those people are never going to talk to each other, yet they both picked up my call. So we're going to see that there's a lot of just these single dangling calls, more or less, coming from this phone, where it just goes to a person. There's no real connection between any of the people that it's calling. So these are all things that are very easy to recognize once you have data in this graph format. You know, it sounds right, you can explain this, but how do you look at that within a relational database structure? You really can't. So we need to be able to look at things in the context of what they're connected to and how they interact with each other. So with that, this was the quote unquote boring part of the presentation. So with that, I'm going to get into some a real world example of what this looks like. So this is part of TigerGraph Cloud. TigerGraph Cloud is our cloud solution. And one of the great things about it is entirely free. So you can have a free tier solution. You can spin up a TigerGraph Cloud solution entirely for free. And even better on top of that is we have a bunch of great starter kits. So if you go to tgcloud.io, create an account. You don't have to right now, but if you want to, if you're interested in this type of thing, I highly recommend it. Create an account, you'll just have to confirm your email address. Then you can go over to create solution, click on where it says anti-fraud over here. So we have a bunch of these starter kits, which are pre-built graphs. So they already have data in them. They already have a schema. They already have queries written. So you just spin one of these up and you can start messing around with graph however you see fit. So I'll be going over our fraud and money laundering detection one. So you can just click on that. Next, like I said, free means free. So you can spin up a free tier solution, will cost you $0, won't even ask you for any credit card information or anything like that, and you're good to go. And then here you can just give it a name, and you'll need to set an initial password just so you can log in. I'm going to leave it as default, and then a subdomain, which is where you'll actually access your solution from. So we'll just call it as AML demo. You'd click next, and then you just confirm all of this and select submit. It does take about 5 minutes to spin up, so I've already done that, and we'll just be jumping into my pre-built solution. So once your solution does spin up, you'll see your status here changed to ready, and you can access that either by going into applications and clicking Graph Studio, or if you can access it directly using that subdomain that you created before. So this one is fraud.i.tgcloud.io. Now, when you first go here, the first time that you ever visit your solution, we can see that we have a schema here. So here is what our basic schema will look like. We have users. Those users can both make and receive transactions, and they can make payments as well. Additionally, the users have devices tied to them, and users can refer other users. So I can say, hey, sign up for this service, and there is actually a referral bonus for this example. So if I refer someone and they sign up, I get a referral bonus, given that they actually use their account or something like that. So one thing to note, this is our global view. It's kind of an overview. To get into our actual graph, we'll need to click on the graph itself. This one's called anti-fraud. This will bring us to pretty much the same schema, where we'll just see these globe icons, which represent that this is in the global schema as well. But that's enough about that. Let's get into actually identifying things here. So if we hop into our queries, we can see, let me just clear this. We can see that we have a couple demo queries that have been included. Let me make this a little bigger, actually. There we go. So this one is for determining if someone is doing that invitation fraud. So like I said, there's a referral bonus for referring people. So what's to say that I don't just create an account, create another account, and then use account A to give money to account B. So that way it looks like an active account and I get my referral bonus, and then using account B to transfer that money back to account A. So I've spent $0 and I've gained my referral bonus. So how can you see if someone's gaming that system? And this query will allow us to do that by looking at people, who they've invited, and then any transactions between those people. So if I created a fake account with that referral bonus, I then transfer $20 to that fake account. I wait however long for my referral bonus to hit, and then I take that account and transfer the $20 back to the initial account. We're going to be able to see that due to those connections. So let's see if we can find something here. Go ahead and just grab a random user, and we can see from our results that they have referred another user, and that there are these transactions from our initial user as well. So if we expand these out, we can see that there's not really any connection between these users, and therefore most likely it's not a fraudulent user activity. Additionally, we can take a look at some other stuff with transactions involving money laundering. So this one will take a look at a particular transaction and attempt to identify if it is kind of part of one of those money laundering rings. So I can just put in a random transaction here, and this will return a graph of all of the connected accounts. So what this will do is it will traverse and it will get the accounts that are connected to that transaction. So remember, a transaction has someone who sent the money and someone who received the money. So that's what we're getting from these two clusters over here. And then additionally, what we're doing is expanding out from there all of the transactions that any of those users have taken part in and other users who have taken part in those transactions. Basically, what this gives us is this is more or less a straight line. There's no real round loop here, or at least not a clearly defined one that would say this transaction was part of a money laundering schema or money laundering scheme. So we can try this with just a couple other transactions. We can see sort of what those interactions look like. This one, again, does not appear to be fraudulent. I'm trying to remember if I do remember the number of one that is. We'll get to that later. You will see some fraudulent transactions and they will be very easily identifiable. But again, this one is looks standard as well. There's no real loop here, easily defined loop between any of these users and that particular transaction. Let's see, what else do we have here? This one is looking for, again, kind of those repeated payments. So it is looking for someone who received money, getting all of their transactions and who sent them money. And then from those senders, going out to see who sent them money. And again, trying to recognize those circular inputs that may be something representing a fraud ring or other type of fraudulent service. So we can see here this transaction web, starting from our initial input person. You can see all the transactions that they've taken part in and kind of how that money has flowed around through the different networks. So each one of these densely populated areas is kind of a network of people making transactions within each other. So we can see that these users interact all with this user. So this is most likely some sort of merchant or something who is receiving these payments from these different groups of users. And we can see that as well, kind of expanding out through our entire schema, or through the entire return, rather. Let's see if we can see something else from here. So this one is a bit more clustered. But either way, we can see that this is most likely not a fraudulent user because kind of their network of transactions, this is someone who doesn't really interact much with other transactions. They're sort of this lone vertex here in this graph. Same receiver, same sender. So this is, again, kind of trying to recognize those fraudulent fraud rings, money laundering type stuff. So we're looking at instances where people have been creating a fake account and then sending that money back to themselves. So this is very similar to that first scenario where user A makes an account, gives money to that account, so that way they get that referral bonus and then transfers that money back to themselves, so that way they get their money back. So this user, we can see, has actually a few of these where they've paid out to another user, and then that money has kind of been transferred along either to another user and then sort of back to our initial user. Just explore that again to see some more of these connections. So this one is pretty blatant. These two users have just been sending this money back and forth between each other, and they even share the same device that they're using. So that should be pretty telling right there of what is going on, where both of these users are logged into the same device and they're sending money back and forth between each other. This one, again, is a similar approach to that last one. So that one before was looking at how users were sending money back and forth between each other. This one looks at the actual amount of money that they are sending between each other. I want to let me run this. We'll come back to this one in a second. Not sure why it's not letting me in the run. But anyway, this is kind of the big one. This is that money laundering detection. So this is looking for those circular transactions between different groups of people. Let's put in, let's find some random users here and see if we can identify a fraud ring. So this basically returns back the total, any circular paths from that user. So this one is in the center of a lot of things. There are a lot of transactions that are going around, a lot of these different loops that are circling back in on each other, and a lot of interaction between the different elements here. So this is most likely starting to look like something a little bit suspicious, but just to verify that, we'll see if we can get some other data here and see what some other individuals look like. Now, this one, on the other hand, looks very suspicious. So we have these clearly defined loops here where we can see that money is being transferred through these different accounts, and it all comes back to this user here. So this, I would feel confident in saying that this is a money laundering ring because of the circular nature of these transactions, because the fact that there are multiple of these circles, and the fact that a few of them even combine back into each other or split across to branch back in. So this is most likely 3 different avenues that this person is taking in order to launder their money and get it back to themselves. So it's pretty interesting how we can take a look at just those connections and explore the connections between people, the devices that they're using, and the transactions that they're making in order to identify things like this, where it is highly likely that they are engaging in fraudulent activity, whether it be money laundering or otherwise. And then this one initially also tries to apply a fraud score to identify things that may be fraudulent transactions. So we can kind of specify how picky we want to be looking for suspicious transactions. And we can see here that it is returning back any of those suspicious looking interactions, as well as any of the payments that those suspicious users have made. So this is that same user that we were looking at from before with all of our circles in the fraud ring. And here we can see that it has identified quite a few potentially suspicious interactions that are being engaged between that person and the people that they are connected to. So that's a very high level overview. I would love to explain how all these queries work, but unfortunately there's not enough time in this session to do that. So I highly recommend that you check out this starter kit for yourself if you're more interested and would like to kind of take a deeper dive into these queries and exactly what they're doing. Also, feel free to hop into our community, community.tigergraph.com. We have a very active developer forum here where you can submit any questions. And we also have a Discord channel as well, which we are always answering questions on and always happy to help out with. So I guess with that, I'll kind of open the floor up to any questions. I see a couple came in, so I'll try and touch on those first. But if anyone has any questions, feel free to put them in the chat or raise your hand. Not sure exactly how we want to handle that, but I'm happy to answer questions whichever way you want to ask them. So let's see. Do the fraud solutions use any standard data formats? I don't believe that this one does. This is, like I said, this is just purely a built out demo to sort of represent these types of things, but there is absolutely nothing preventing you from loading in real world payment data. So when I was working, the example where I said where I found fraud, I was working with healthcare data, and we were working with actual healthcare claims and healthcare transactions. So we had those loaded in their relevant industry standard formats for those procedures. So there's nothing preventing you from loading in any type of data that you want into Graph and letting it assume any of those formats that you are looking to work within. So I was working within healthcare claims and ICD codes. So I kept those sort of in their native format and was able to gain further insights through the Graph and their connections to each other. Are there any more questions that I missed? Best way to learn TigerGraph. That is a fantastic question. So we have a great developer site here. So this developer site will not only allow you to access our community. We have, like I was saying before, we have a community forum, which is a great place to ask questions. And we also have a community Discord. Again, great place to ask questions, get insight from other people, see what other people are working on. We have a bunch of educational content on YouTube. So you can go ahead, go out there and check out that content. And we also have a bunch on our GitHub page as well, where you can view sample projects and look at some of the different connectors that we have available to be able to be used. So I highly recommend you kind of start here, take a look at our YouTube channel, and then our community forum and Discord. We have specifically a TigerGraph 101 video, which pretty much gives you everything you need to get started with TigerGraph using this Graph Studio interface, this Graph Studio. But one of the really cool things is everything that you can do through Graph Studio, you can do via a REST call. So any of these queries that I'm running, I can make a REST call and run them. I don't have to be in this interface. Any of this schema design that I was doing, you can do that from a REST call. You want to load in data, do it from a REST call. So you never have to touch Graph Studio if you don't want to, but you still have that flexibility to do everything you can do in Graph from whatever language you want to do it in. We have a Python connector, we have a JavaScript connector, we have a Java connector. However you want to use it, go ahead and work it into your application. How to deal with unbalanced data sets such as fraud detection data. I mean, that is kind of one of those real world problems where you're never going to be able to balance your data set. And that's kind of where Graph in a way can show its advantages, is because unlike something like machine learning, where you need a balanced data set in order to train a machine learning model, with Graph, you're not really training anything. You're viewing the connections that are already there. So when we were looking at these types of circle detections and anything, there's no fancy machine learning or anything going on in the background. If there is a circular connection, we are going to recognize it. Does that mean it's fraud? It doesn't necessarily, but the point of the matter is that at least right now with the tech, there's no real easy way to say 100% this is fraud. That's why we have all these false positives and why we're working towards reducing them. I don't know that we'll ever be in a world where there's going to be zero false positives as far as this goes, but with the additional technology and the additional insights and that feature generation that Graph can offer, it's certainly helping us reduce that and to get a better idea of our data. So at the end of the day, unbalanced data sets are what they are. You're going to, that's just real world data. But the goal of Graph is to help take out the reliance on needing a balanced data set, because you're actually looking directly at the data itself and looking at those direct connections within that data to form your insights, rather than relying on a model that's been trained properly to do it. So, with those additional features, you can help generate better data for your model, so you have fewer of those false positives. But at the end of the day, Graph will unfortunately not solve the unbalanced data problem. It will just help to generate those additional features, so that way it can better train your model, even if the data is slightly unbalanced. Since I was doing healthcare claims, is this secure? Is there a non-cloud-based? Yes, so TigerGraph Cloud, like I said, it's cloud. You can get it through any of the big cloud providers. So you can go through either GCP, Azure, or AWS. If you don't trust the cloud, perfectly understandable, and you could install it on-prem. If you go to, I believe that's on TigerGraph.com, start for free, and then in the cloud on-prem, download now. You'll just have to enter a little bit of information, but we'll send you a file to help you get set up, and then you can just install that on whatever local on-prem machine you want to run. You want to run it in a VM on your laptop, doesn't matter, go for it. So if you're looking to get started, cloud is the easiest way, just because you can spin up the starter kits. But obviously, if you don't trust the cloud, having your data on-prem is a fully viable option as well. That being said, with a lot of our cloud stuff, it is constantly improving, and with some of the new features in TigerGraph 3.2, we've changed per vertex attribute or access. So you have something like that healthcare graph, where potentially we have something with PII or PHI in it, and we don't want everyone with access to that graph to be able to view that PHI. We can say, hey, this vertex contains information, and we only want this subset of users to be able to access that information within that vertex. So there is getting much more granular control. New to graph databases, how does TigerGraph compare to Neo4j or Amazon Neptune? Oh boy, all right. I will first specify that I work for TigerGraph, and I'm saying this, I'm giving this demo working for TigerGraph. I will also say this using that I have used both Neo4j and Amazon Neptune. My first introduction to Graph was with Neo4j, and at my last job, we also tried to look at Neptune to see if it was a viable alternative or also a viable option alongside TigerGraph. What I can tell you is that if you are building a real-world graph that you want to see real-time insights out of, so if you are building something at scale where performance is important to you, then TigerGraph is your only option. I'm not saying that because I work for TigerGraph. I'm saying that as someone who has used other graph platforms, and that is why I came to TigerGraph, because no one else performs at scale like TigerGraph does. Neo4j, you want to have a multi-tenant cluster, you want to separate your graph on it. Oh, great. Now you have to shard your schema. You have to have a different schema on each one of those nodes. And now that you have a different schema on each one of those nodes, you have to write a different query for each one of those nodes. So that to me is just ridiculous. I want to put my database on multiple machines so it's distributed, and I don't want to have to write a separate query for each one of those machines. That's absurd. TigerGraph, you spin up your thing across as many machines as you want, you create one schema, you write one query, you're good to go. With our new stuff in 3.2 and the ability to deploy to Kubernetes, you want more compute, click that little up arrow to spin up more pods, and there you go, you're all set. Neo4j is just not as, it's Java versus C++, that's really all you gotta say. And then Neptune has a very similar sharding problem as Neo4j, where you really have to separate out all of your different servers and services and the schema within them, and maintain that uniquely across each one of those different devices. And it's just an absolute nightmare to try and manage a solution like that. So it's, I really will say, if you don't want to take my word for it, go ahead and try and spin up a 20 terabyte Neo4j solution, and you'll be coming back to TigerGraph before it's even done loading the data. So that's all I'm going to say. Has the strategy been used for COVID detection and prevention? If not, would it be because of lack of data? So it's funny that you mentioned that. Going back to our starter kits, we actually have a COVID-19 starter kit that you can explore as well that has some real world COVID data related to kind of the spread of that and how it all looks. Obviously, this isn't a full data set. Someone who had access to that full data to gain a more holistic approach Graph would be a fantastic solution for keeping track of things like contact tracing. I mean, contact tracing already lends itself to a graph. Person A interfaces with person B, who interfaces with person C, who is at X location. All these other people were at X location. Now you can see very easily those connections between those people, that location, and how you could trace back any interactions potentially with COVID because of that. So Graph is the next generation way of storing and analyzing our data. I will say that. Whatever graph you want to use, I don't care. As long as you are learning Graph and you are prepared for the world where Graph is going to be the de facto standard, then you are going to be in a good place. Because that's the way things are moving, that's the way everything's going. And frankly, there's just so many advantages to the insights that can be gained through a Graph database versus a traditional relational database. You know, you're not going to use Graph to store your credentials for login or anything like that. There's still some areas where there's very simple databases where relational does make sense, but anywhere where you're looking to combine multiple data sets or take a large subset of data and gain further insights into it based on how it's connected, Graph 100% of the way. You shouldn't even be thinking about anything else. And like I said, I implore you, go ahead, try out other Graph providers, try running them at scale, try doing those types of things. You will find that they are not as performant as TigerGraph, and if they are, I'd love to hear about it. You know, we're constantly working on making our product better and things like that. So I implore you all to try out as many different Graph solutions as you want and sort of see what works best for what you're building out. But as long as you're thinking in a Graph manner and you're using Graph, then that's really what I want everyone to get out of this. So I guess with that said, kind of done enough rambling there for a little bit. Any further additional questions, feel free to put them in chat or raise your hand if you would like to ask them via voice. Happy to answer whatever questions you have. Is there a maximum data size before it breaks? That is a challenge to you. We have graphs with hundreds of terabytes of data in them, and they're still able to run queries in real time. So if you can break it, then you have significantly more storage space than I have access to. So we have not found the limit yet. Cool. So last call for questions, and then I'll stop hogging everyone's time and you can get back to your days or evenings. Or mornings, I guess. I have no idea what time it is in the rest of the world. Yeah, thank you all for attending. And I hope you enjoy, and I hope that I've at least helped spark your curiosity about Graph. Ideally, you know, I'd love for you to try out TigerGraph, but really try out whatever graph you want, see how it works for you, see how you can ingest your data and do things with it.